Today we're looking at Lesson 5.1, which is solving linear inequalities by addition or subtraction. Today in class we talked about, for some of you, we talked about when you're solving linear inequalities, it will be the same process as solving an equation with an equal sign. The only difference is instead of having an equal sign, you're going to have an inequality symbol instead. But you're going to bring the inequality symbol down, at least when you're using addition or subtraction to solve, until you get to the very last step where you have the same symbol that you started with, just like when you had an equal sign and you brought the equal sign down as you solved the equation. I wanted to show you that the textbook talks about set builder notation. We're not going to be requiring to do set builder notation for our answers, but I want you to be able to understand what it means. So in looking at this example here, this would say, if you were to read this, for all values of x, or for the set of x values, x is less or greater than 20. So this part means for the set of x values. What you need to have as your answer, and it doesn't need to be in set builder notation, would be just the right part of this statement here. That would be what I would be looking for an answer. You do not need to add the extra x with the vertical line and the extra bracket symbols. Now I've also put at the bottom here the inequality symbols that you might come across. There's different words that represent these symbols. I've shown you the basic words, but there's also other words that can represent these symbols. You have less than, which is the first symbol, greater than, less than or equal to. Sometimes you might see at most or no more than would be something they would say there instead of less than or equal to. And then greater than or equal to, you might see at least or no less than. Those would also be words that could describe those symbols. But whenever you're looking at symbols, you always want to read from where the variable is. Okay, so if the variable is on the right side of the inequality, you want to read from the right side. If it's on the left, you want to read from the left side. So we'll show you a couple different examples here. This one we're going to solve for m. So like I said in the beginning, that we were solving just like a basic equation, and instead of bringing the equal sign down, in this case we're going to bring the inequality symbol down as we solve. So we're going to solve for m by adding 8 to get m by itself, and we get 30 is greater than m. Now, the answer is fine written like this, but when you read the answer and you use the answer to graph on a number line, you want to always read from the variable side. So in this case, the variable is on the right, so I have m is less than 30. So if I were to do a number line here, I would put a point at m is 30, which is the first one. Oops. I'd put a point here, and then it's reading m is less than 30, so I'd have to put an arrow pointing towards numbers that will be less than 30 on my number line. Notice I also put an open circle at 30. The open circle is there because we're not actually counting 30 as our answer. It needs to be numbers less than 30. So we don't want to include 30 in the answer, so we're going to put an open circle at 30. And then we point our arrow towards numbers less than 30, which is what our answer says. This one we're going to do the same thing, solve for D, but we need to add 14 to get D by itself. Bring down the symbol, and I get D is greater than or equal to -5. So if I were to do a number line for this, I would need to put a dot at -5, but this one would be closed because it includes the fact that -5 is an answer because of the symbol. So the symbol is greater than or equal to. So since it's also equal to -5, we put a closed circle at -5. Now it's greater than, so I need to point an arrow going towards numbers greater than -5, and that would be my number line. Here, we're asked to, again, solve, but we have 4 answers to choose from at the bottom of the screen, so we're going to solve for P first by getting P by itself, bring down the symbol, and I am left with 18 minus 8, or 10. So I'm looking at which ones I could eliminate, and that would be the answer. So I'm looking for answers to eliminate. The answers that don't have 10 would be ones to cross out. Then I need to match the answer between F and G with the symbol that I have. So G would have to be the answer. And notice they put the answers in set builder notation, but you can still read that G means the same thing as what I got for my answer, which is P is less than or equal to 10. Here we have variables on both sides, so we're also still going to solve for n, but we need to combine like terms first. So I'm going to bring the 9n over to be with the 10n so that I have something on both sides of the symbol. I have -1 left, and then 10n minus 9n is actually 1n, or just n. So we actually don't need to do any more solving. So my answer, if I'm reading from the variable, is going to be n is greater than -1. On my number line, that means that I need to put a open circle at -1 because I'm not including that in my answer. And then greater than would mean I point my arrow towards numbers that are greater than -1. Something else I use to remember which way the arrow goes on my number line is less than is always going to go to the left. So think of 2 L's, less than, left, less than, left. And then here we have another example of variables on both sides. So we're going to solve for h, bring the h over, 4h over by subtracting, and that also gives me 1h, or just h. So my answer would be h is less than or equal to 12. And since 12 is included in my answer, I'm going to put a closed circle at 12. And it's less than, so it goes to the left. Notice less than to the left is only going to work if you set up your number line least to greatest. So if you always have your numbers on the left side lower than the numbers on the right side, it's always going to be less than, the arrow goes to the left. And then we have one more here where we're going to write an equation or an inequality, and then we're going to solve it. So this says, just like when you're reading a word problem and trying to come up with an equation, you're going to do the same thing here, read the word problem, except you're coming up with an inequality. So we're looking for keywords that might tell us what the inequality symbol is that we're going to choose, because we have 4 choices. So it says Sanjay has $65 to spend at the mall. So think about that for a second. If $65 is all he has, does he have more than $65? No, he has $65 or less. So if we want to come up with a symbol for that, we're going to have to do less than or equal to $65, and that's what he has. Now, if he bought a t-shirt for $18 and a belt for $14, that's going to be added to what he's buying. Also, at the end here, it says he wants to buy a pair of jeans. So we don't know how much the pair of jeans are, but we do know that he bought something for $14, he bought something for $18, and he wants to buy a pair of jeans, and he only has $65. So we would set up our inequality like I just wrote. Then we'd combine like terms. And to get how much we have to spend on the jeans, we would need to get x by itself. So x would have to be less than or equal to $33. And that's how much he would be able to spend on his jeans, $33 or less. And that concludes Lesson 5-1.